The FiX1 is the fixed installation scanner, which is what we call the FiX1, used for obtaining volumetric data of stockpiles and structures, stockyards, and mining operations. The FiX1 scanner from Carlson provides simple automated method for obtaining point cloud and volumetric data of monitoring areas and stockpiles of many different installations. It does the onboard analysis of the data and gives you a variety of connectivity options to ensure continuous operation in multiple systems in a network. So you can see here is just some general screen grabs of some of the results that we can get from this. First, how does it work? You'll be interfacing with the FiX1 through a common web-face interface that provides across 3 connectivity options. So you can connect to it via Ethernet, Wi-Fi, or through a cellular card. The web UI presents a complete history of the scans and volumes that the user can download if required. You can schedule your scans, report the completion and volumetric results via email and SMS. The web interface also provides access to all the settings, diagnostics, such as scheduling and such. Fault reporting can be accessed to the web UI and alerts sent to the email. And maybe people could mute their mics, might make it a little bit easier in case you have any trains or dogs. The software in the FiX1 can be remotely upgraded through the web UI, and the future multi-system configuration can be configured and accessed through the single interface. So what this is telling you is there's no software that you have to download to a PC or customer's PC or your PC. Everything's handled on board, the onboard PC on the FiX1. As you can see here is just an example of what the FiX1 looks like for those who've never seen it. We have the mounting point, the integrated computer with connector series in the blue section, and then the housing with the motors and the lasers in the white section. If a volumetric scan is activated, the FiX1 will generate a point cloud, extract the region of interest, and calculate the volume of material in that area. The volume is presented to the user through the web UI without any further need for manipulation. Volumes can be verified by examining the linked point cloud data for foreign objects and anomalies. So what that means is if you get a volume that does not make sense, you can connect to the web UI, select the scan, and then open it up into the point cloud viewer and look and see if there's a truck in the way or if there's no data or whatnot. It gives you the ability to interrogate what is collected. Volumetric accuracy can be defined through user-defined settings in the laser and angle resolutions in the web interface, which we'll go over shortly. The web UI provides a graphical representation of how volumes have changed over time. And this will be a future development, which is very short in coming. The data from multiple FiX1 systems automatically stitched together based on references created during the installation, and therefore total volume can be calculated without the need for manual intervention. So what will be coming shortly is our multiple unit systems, where basically the one of the FiX1s will act like a hub, and then the other FiX1s associated with it will act as a spoke, and we'll get into that a bit later. Laser scanning. By default, all the cloud's data is stored inside the FiX1. If in the event that someone needs to download it, they can go to the web UI and download it in an LAS format. Like the volume calculations, the resolution of the point cloud data can be configured through the web UI, which we'll get to in a bit. Point cloud manipulation and processing can remain invisible to the user for regular operations. And then, of course, with the future, with multiple systems, the FiX1 will take the data in from multiple FiX1s into one FiX1 and then stitch all the georeference point clouds together and get you a volume based on that. But that is, like I said, in our future development, which is short on the cycle. Some of the key specifications for the FiX1. The maximum range is 250 meters or 820 feet to a 90% reflective target. As you guys know that play with lasers, that's an important distinguishing. The minimum range is a half a meter, or that's not 19.7 feet. I have to change that. That's 19.7 inches, it should be. The range accuracy is plus or minus 10 millimeters, or basically a quarter of an inch, or 0.4 of an inch, to 90% reflective target. Now, the maximum measurement rate, it can pulse up to 15,000 points per second. The weight, it's got some weight to it. It's about 27 pounds or 12.5 kilos. And the size, it's about 495 millimeters by 314 millimeters, or 19.5 inches by 12 and a quarter, or 12.4 inches. But what's important to know about this, it needs to have 368 millimeter or 14.3 inch clearance around it for movement. Another important thing to keep in mind is the operating temperature. It's rated to operate at minus 40 degrees centigrade to 50 degrees centigrade, which that magic number is minus 40 degrees Fahrenheit to 122 degrees Fahrenheit. So that's the operating temperature, which is normal. Most humans don't work in those types of temperatures, but you need to be aware of that. And it also is IP67. And that's a good thing to know, that it's not too flimsy. And also it is a class 1 laser product, so it is eye safe. All right, so the FiX1 base system, what do you get? Basically, it's a very simple system. What you get with the base system is you get the actual Carlson FiX1 region specific, which we'll get to in a second. You get a mounting plate, a fixing kit with basically 4 sets of mounting screws, 1 region specific power cable, 1 test Ethernet cable, 2 external antennas, 1 for the Wi-Fi and 1 for the cellular, and 1 FiX1 packing case, as you can see here. So like I said, it's all self-contained and easy to go around. Now, to keep in mind, this is not meant to be a portable system. It's meant to be installed once and you leave it there. So it's really, we didn't go too much elaborate on the case. Now we'll move on. That's the hardware. We're going to move on to the web user interface. The users can access the FiX1 web user interface, or the UI, by simply accessing the assigned IP address to the FiX1 by any of the mainstream web browsers. We've tried it on Chrome, Explorer. I've done it on my iPad. So the browsers, it's pretty much work on any browser. Now I haven't tried it on Netscape, but that's going a little bit old school there. The intention is we ship the FiX1 with a static IP address so the customer's IT department can configure the FiX1 to work with the customer's network. Once they connect to the system, they'll be faced with a login screen, and then they can change the settings so that way it can conform to whatever IT network that they're putting it into. Once you get into the web UI, the FiX web UI has a simple navigation ribbon at the top of the window. This ribbon will be displayed at the top of the window no matter which page you're in on the FiX1. And on the ribbon, it shows you the serial number of the FiX1. Then you have a couple buttons up there. The logout, that'll allow you to log out of the FiX1. The scans will take you to the scans page where you can see the current activity and past scans and existing scans. The schedule will take you to the scheduling page where it allows you to schedule scans. Settings, no surprise there, takes you to the setting page where you can configure the FiX1. And the language, there's a language drop-down that comes there, which you'll see, or you can select the language at the bottom at any time. So if you get stuck and throw it into Russian, you can easily go back out to English. So this is what you'll normally see when you log into the web UI after you get to the login page. What you can see here is either 1 or 2. You can see here the scan history. It displays it as per scan or on a graph-like situation here. If the system is scanning, you would see the scanning going here. So this allows you from this page to access any of these scans, and from that point you can interrogate them and look and see what's going on there. What you see here is the scan number, the time start, the amount of time it took to run, and the volume. Right now it's telling us our next scan was, this was created yesterday. This is the Maysville scanner. It's saying the next scan would have been at 12 p.m. on 4/23, and it's part of an hourly scan test that we have there. You could toggle in between these two displays by simply choosing, this is the graph. You select there and it'll go back and forth. In the scan history, when you select on one of the scans, it gives you a couple options. You can hit view, which view the point cloud and the point cloud viewer. You can download the data. You give a couple options. It can be downloaded as a binary file, an LAS file, a grid file, and a volume report, and a full report, which is something that we're working on right now, which should be incorporated in there, which would be sort of like a PDF that incorporates a little bit more panache to the results. You can delete the scan from the system, or you can reprocess it. Now, reprocess it means if you want to go change some of the scan settings to change maybe the base tin or something like that, or change the coordinates, you just reprocess it there. This is what you get for every scan selection that you get. And just a word of note, a lot of these files go into P3D without much of a problem, since we were using P3D as sort of a tester, and some of the programmers involved were involved with P3D. This is the point cloud viewer that it takes you to. This will allow the user to manually interact visually with the point cloud. This is what you get through the web UI. It opens up a separate window. There's a lot of things you can do, and you can do measurements and stuff like that, but it will display to you the bottom surface and the point cloud collected. What you see here is the breezeway that was collected in Maysville. Well, we'll look at that a little bit later. But this is something that everyone can do if they select the scan and they select the view icon. The web UI, the scheduling page, very straightforward. This allows you to view it daily, weekly, or monthly. It allows you to set your scans. You can set for repeatability and stuff like that, simple dates, repeats every hour, delete or skip. So this allows you to plan what you want. Now, obviously, I don't think anyone will be setting it for hourly scans. We were doing that just to test it, to break it. But this is what you would set for when you want the scans to happen on a regular basis. The settings page. All right, so when you go over the settings page here, this is where the muscle in the brain is of the web UI. Underneath the setting page, you'll have a calculations drop-down, information drop-down, reporting drop-down, scanner drop-down, and network setup options drop-down. And we're going to look at each of those in turn right now. The important part is obviously the calculations drop-down. This is probably one of the most important aspects of the setup. This is where you put in the base coordinates for the scanner. On the base plate coordinates, you can put your easting, northing, elevation, or X, Y, and Z. It allows you to upload multiple different surfaces, which you can select. This will act as your lower limit for your volumetrics. It allows you to put in your base plate orientation. And then it also allows you to manipulate your grid options. Since the volumes are computed on a grid basis, you can expand your grid to make it bigger. So that means there's more cells. And also a bunch of different aspects there for the surface math. And then the vendor options that you see there are the calibration values that we set up in the factory for it. So these are the things that pretty much, once you come in here, you're going to come in here once, and then you're going to maybe come back to the bottom surface, maybe in the future if you wish to change it. But this is the bottom surface that's used for your volumetric. The next thing is the information page. This one just gives you a simple what the temperature of the unit is, the voltage, how long it's been running, and what version of software that it's running right now. And as you can see here, there's update available. You can hit that automatic update, and there's a restart. The next thing is reporting. We're going to be looking to expand this more in the future as we get more feedback from the field. In here, it gives you, if the customer wants to know what the weight is, obviously we need to know what the density is. So you can put a density value in there. So like, for example, kilograms per cubic meter. Then what that will do is if you say show weight, it will just multiply that number by the volume, and it will display on the scan page the weight versus the volume. Also, you can set some alert thresholds. So if you take a look on your scan screen in the graphing section, if you this will create a maximum and a minimum, which will show when the scan happens, where it lies within it, and then future alerts will be triggered if it steps in or out of that for you. But these are all user options, and also, like I said, this is something that's going to evolve as we get demand from the field and feedback from the field. Now, we're going to spend a little time here on the scanner page because a lot of the definitions aren't exactly straightforward, and it's very important that everyone understand that if you're going to demo this, what each of these settings do. So when the FiX1 is scanning, the body of the FiX1 rotates horizontally at a relatively slow speed, which you can see here. This is at the rotation, while at the same time the laser head rotates vertically at a higher speed. So you're going to have basically it moving in two axes at a time. The laser itself is firing constantly at a predetermined rate. The results is a pattern of a radial scan, lines drawn beneath the FiX1. The scanner settings allow you to adjust the density of the angle between the radial lines, the density of the points along the lines, and the extent of the ground that the lines cover. So you can see here to the right, there's vertical coverage, horizontal coverage, scan line interval, head rotation, and laser rate. These are the options that the user has the ability to manipulate, and we're going to go into that right now. So the first thing that's important is your estimated run results. So adjusting the scanner setting changes the duration of each scan, as well as the number of points that will be collected. Now, obviously, this is important because if you want to run a scan every hour and the scan takes an hour and a half to do, you're going to run into a problem. So usually the larger area that the FiX1 needs to cover, the longer the scan duration will tend to be and more points will be required. So as you change the settings on the UI, it will change it on the screen for you and tell you about roughly how many points you'll be collecting. So the first thing we're going to talk about is vertical coverage. All right, the vertical coverage determines the vertical extent of the scan. 180-degree vertical coverage would survey everything up to a horizontal plane from the FiX1. So basically, if you look at it, if you really think of the FiX1 as sort of your nadir point, so everything that goes out from 0 to 180 from it that's flat, that is what the 0 to 180 covers. When you start to increase it past the 180, then it starts to scan up on itself a little bit. So that all depends on what you're scanning. So the drawing shows here at 70 degrees angle, as you put, that would be in there, that's what a 70 degrees angle would be represented in the field. The selected angle should ensure that the whole area of interest is included in each scan. That's going to be important when you go to setting up the instrument or setting up the probe and the installation. The horizontal coverage, a little bit more straightforward. The horizontal coverage determines the horizontal extents of the scan. Once the FiX1 is installed, this will almost always be 360 degrees to ensure full coverage of the area beneath the FiX1. Now, you can have it go on itself twice. So if you increase that number above 360 degrees, that means it'll keep on going around the circle. And there's some situations that some people might want to scan the whole area twice for some reason. That just gives you the ability to do that. But normally 360 degrees is more than enough. But you could say, for example, if you have it set up on the edge of a stockpile where you have multiple units, you might want it only to scan maybe half of that forward. So that way you're not collecting useless data. So here's where you're going to come to optimizing your scans when you relate it to other FiX1s. The vertical coverage, wrong direction. All right, scan line interval. This is where it gets a little bit confusing, and this is where we're going to work on this terminology for a future upgrade. The scan line interval determines the distance between each radial line that is scanned. In effect, this controls the speed that the FiX1 is turning horizontally in relation to the vertical spin of the laser head. So currently, the value that's shown is the encoder count, which is the encoder count divided by 65,000. But we're going to be changing that to degrees to make it a little bit more user-friendly. So this is where it gets a little bit odd when you start to manipulate it. So right now the scan line interval is set to like 100, here for example, it shows 140 steps. That's moving at a pretty quick pace, so normally it's 21. The head rotation. The head rotation controls the speed of the vertical rotation of the laser. That means the vertical, all right? We're not talking horizontal. The horizontal is controlled a lot of times by the scan line interval, turning horizontally. Here on the vertical is the head rotation, controls the speed of the vertical rotation of the laser head. All right, given that the laser is firing at a fixed rate as the head is turning, for a larger scan area, the rotation speed might want to be slowed down so that way you can increase your point density. So it's all, you want to get yourself the best setting from how far the target area is to you. So obviously you run as fast as you can, you're going to get a sparser data set, or if you slow it down, you're going to get more of a detailed data set. So this is also what a user setting will decide from the field and what you're doing and how many units you have and stuff like that. So this is something that you might be adjusting to optimize your scans. Laser rate, this is very simple, straightforward. The laser rate controls the speed at which the laser is firing as the head turns. Usually, everyone leaves it at the minimum because 5,000 points per second is quite a lot of data for this particular type of applications. But if you're working in a larger area that's further away, that has more area you have to cover, you might want to increase the pulse rate so that way you get a higher density. So together with the head rotation rate and the laser rate determines the density of points along each radial scan line. So that's just something to keep in mind. The only benefit you really get with doing it short range, if you pump it up to 15,000 hertz, you're going to get a lot of data, and I think there's a point of diminishing return. That's it for the scanner page. Now we have our network setup options. We go more into this with training. With the network setup options, you can set up your Ethernet settings, your Wi-Fi settings, and your cellular settings. In here, if it's Ethernet enabled, what's important is you can see the dynamic. This will be important to the IT departments that are setting this up because, as you know, most of the devices that you connect to a network are dynamic DHCP. They're assigned an IP address from the router or from the server. So when we send the units out of the factory, they're going to have a static IP, so that way we'll know the IP address, so when the user gets it, they can connect to it. Otherwise, they have to go through some tricks to find it. So this will be detailed more in training. And of course, with the language options, at the start with language, it is supported right now in English, Spanish, French, Russian, Mongolian, and Chinese. As you can see, there's not a lot of language to change. So if there is a specific language that you wish to be included, we could look to do that. It's just a simple language file, and it shouldn't take too much time. So that's where we need some feedback from you. FiX1 installation, it's very simple and logical. This is something that we wish we had some more experience on, but because of that little global epidemic or pandemic, I guess you can call it, of the COVID, it has stymied our field deployments because we can't really get to anywhere. So right now, some of what we learned from where we have installed it, obviously one of the most important things for the installation is the line of sight. So the FiX1 system can only measure what it can see, LiDAR 101. So what's important when you think about it is the target area of footprint, what you want to measure, the height of the material. Do you want the FiX1 to be above it and looking down, or on the side? That's what's important. Obviously, obstruction, superstructure, cranes, and belts. You want to make sure that you have the best vantage point for your FiX1 or your multiple installations if you're looking for that. Another important point about the setup: stable platform to mount the FiX1. You don't want it moving. You want it rigid. Environmental concerns, vibrations, temperature, and moisture. You don't want it vibrating during the scan, as that can influence your data, as you know. Temperature, you don't want to see great sudden swings in temperature, meaning you don't want to put it right next to a vent or right next to an AC unit, because that could cause some weirdness when you start rapidly heating and cooling stuff. And of course moisture. It is rated IP67. But moisture could cause issues in the long run with, obviously, visibility and such like that. The other thing you want to think about with your installation is connectivity, how you can get the power and data to it. You need power and you need data either via Wi-Fi or Ethernet. And then, of course, one of the most important things is surveying the mounting plate. And we have that in the guide to do it. But one thing to keep in mind, what's common to all this is the mounting plate must be plus or minus 1 degree of horizontal level, up or down. Anything greater than that will put some more stress on the bearings and such, and will lessen the life of the instrument. All right. So when you install it, you want to make sure it's relatively level, within plus or minus 1 degree. Right now, we have the system that's been installed in Mongolia now for many, many months. As you can see here on the left, we have, this is how they have it installed in Mongolia. And it's been working pretty consistently now for, I think almost pretty much 3/4 of a year, half a year. As you can see in the middle is the example of the data that it's receiving. And then the image on the right-hand side, in the lower right, is the actual, what it looks like, what they're scanning. So they have it up there, they scan once or twice a week, and they look at the results. And they've been fairly happy with the results. This is one of our prototype units that's in Mongolia. And they're waiting on, I think, Alex, they're happy with it, and they're going to be looking to potentially purchase more with the multi-unit system. The other installations we've done here, we've had, we got these out to China before all the travel restrictions came in. As you can see here, these are our distributor in China is doing some demos at an iron mine. As you can see here, they're going to be loading moving iron, ore, and stuff around here. So they made a demonstration mount, as you can see at the bottom. And you can see that's where we mounted the FiX1 to, just for the demo. And you can see on the upper right-hand corner the results. So they were fairly impressed with it, and they had a lot of feedback for us. So this type of application would be suited because normally you can't go get a volume in that area, and having a person there gets labor intensive and stuff like that. So this is an example of how it's used in an iron mine demo in one of those other applications. Right now in Maysville, we have our first U.S. test installation. Everyone's fairly aware of the, I guess you guys call it a breezeway. So what we've done is to part of the testing, we're starting to compare the results. So what we did here, as you can see on the left-hand side of the screen, this is what the FiX1 sees in the PO tree, which is the viewer, and in the right-hand side of the screen are the P3D LAS files have been brought into P3D. What we did is that in the middle, you see this little inverted cone. We wanted to simulate a lower extremity of that, because basically the center, where you can see where my mouse is moving over here, this is directly underneath the scanner, and we wanted to say there was maybe a bottom loader or a feeder system underneath it. So we used that as sort of the limiting factor for the volumetrics you can see here and in here over on the P3D. So by combining those two surfaces, we had a result of about 35 cubic meters on the FiX1 and 35 cubic meters from the P3D. And we've been testing this on some other volumetric stuff. So we know that the algorithms are sound that we're using on board the FiX1. And we hope to get more examples of this as testing allows us, but testing's a little bit lagged here just because of the current world situation with restrictions of travel and stuff like that. So coming close to the end here, so sales and marketing resources. What do you guys have available to you to help sell this? Because you can see it's a system that's a little bit harder to demo. So what we've done is we have 2 demo sites, test sites that you'll be able to access that are fully functional. One in Maysville and one in York. These are accessible via the Carlson VPN. So if you have VPN access and you're connected to the Carlson VPN network, you'll be able to go to the Maysville address, which is 192.168.56.150. That's fixed 1907.16, or the UK one in the test room in the UK, which is 192.168.61.123. So you'll be able to link to those at any time when you're connected to the network. We also have which we'll be emailing out to you guys shortly, is we have the complete FiX1 brochure done. We have the FiX1 webpage about to go live, and we have the price list all completed. So we have all the tools for you guys to start to go out there and start showing this. Some of the target markets. This product is something unique coming from the LMD division, where it transcends a lot of divisions or department boundaries. There's a lot of uses in this other than just mining. So like, for example, what initially brought the FiX1 to life was the road salt sand domes that we have throughout the U.S., for example, in Canada, the DOTs, counties, and municipalities. Sometimes that salt is worth a lot of money. They have no way of measuring it. So the idea was to install these in the barns and have them run them, and then they could order salt when it gets past a certain thing. But we've also seen a big spike in covered ore stockpile facilities, like and mining operations, like in Mongolia and China. Other good things that people are exploring right now are stockyards with like stockpiles, and port terminals, for example, like you see in the bottom left-hand here, where you have a lot of ore being brought off ships, deposited, and then they need to get an accounting of the volume, and they want to automate that. But basically anywhere that requires automatic volumetric inventory. So really your imagination and your contacts is what the limits are.